In this video, I will teach you everything I learned in my 3 years of BSc about this numerical computation program known as SciLab. So, if you search SciLab on Google, it says this physics jumbo mumbo. But basically, SciLab is a tool with which you can play with math and physics equation, like plot them, change different variables, and see how they behave. It is just like a digital physics and math laboratory. So after watching this video, you will be able to virtually plot and play with any math or physics equation in SciLab. So let's get started. Now to get familiar with this environment, I just want to tell you something. After working a lot in SciLab, I have learned that some of its features are like extremely useful. You spend most of the time there, and some of them are like not useful. Like you don't need to know how to use everything. So I will teach you the most important things you need to get started and like plot any equation in SciLab, and I will like don't show you everything like every tutorial does, like show everything, and it is just a waste of time. You will never use it. For example, this is variable browser. This is also very unuseful. It just shows you the values stored in your variable. Now if you don't know what is a variable, what is programming, etc, etc, don't worry, in this tutorial you will learn everything. So now variable browser just shows you the values stored in your variable. I don't use it much, but sometimes this is quite useful. This is your command history, like it shows you the history of the commands you run in here in SciLab. Now don't worry about what are the commands, you will learn further. Now this is news feed and this is always unavailable, so don't worry about this too. Now the most important thing in here is this one, that is console. This is similar to the terminal we use in our computer. This is where all the commands of the SciLab will be executed. So this is really important. And also this thing in here, this is known as PSI Nodes. This is also really important, and this brush thing in here is also really important. Like if you ever mess up things in here in this console, you just need to click here and it will clear the console. So now before starting to write commands in console, I just want to tell you something which is really important, and that is docking. Now for example, like you ever clicked in here, this is known as undock. If I click this, what happens is this thing which was here like popped up, it undocked. Now there was an undock button, but there is no dock button in here, so people get confused how to like take this thing back in here, and this creates a mess because if you like undock everything, the SciLab becomes like not much useful. You can also undock this too if there is something else in here. So now how to dock the things back? You just have to click this blue thing in here and move your cursor like this, and then you can like adjust its size. Now other things which we need to dock is this one, so newsfeed. Now this thing in here. Now other thing is variable, click this and move it in here, and then you can like adjust the size as you want. If you don't want to show news feed, like undock it, this is in here, and like cancel it so it will go away, and now you will have variable browser and command history. So this is how we dock in SciLab. If you ever click this button in the terminal, it will simply undock and it will look really weird, so you can like dock it back. And for example, now it's looking more weird, so I will dock this and take this in here, and I will take the variable browser, adjust its size first and bring it back in here. So this is how we work with these different interfaces in SciLab, and this is really important. Now let's start working in this console. The console is where all the commands of the SciLab are executed. Now what is a command? A command is basically something you are telling the computer to do. For example, I want to add two numbers. I will write one number, I will do this plus 8. So I'm telling this computer to add these two numbers with this plus sign. This is everybody knows. Now if I press enter, it gives me the answer is equal to 15. which is right. So this symbol is used for plus sign, that is everybody knows. Now if I want to subtract two numbers, so it also subtracts. Now for multiply we use this star symbol, and now for power we use this symbol or double star. So this symbol and this symbol both work the same way, and you can use brackets to like say which operation to do first, like you do in basic math. Now you can also see in here the history of the commands is executed. Now to run a really long command and don't wanna type it again, you can click in here, double click it, and it will run that command again. So this is the use of command history, but it like never happens. I run commands always like this. For example, if I wanna run like 4 raised to the power 2, so I will press the upward arrow key like this, and if I press it, this goes to the commands which I run, like this is the previous one, it is the previous one of the previous one, and go on to the command which I wanna run. For example, this one, I press enter and the command get executed. So this is the basics of the terminal. Now everything I have done in here can be done by the calculator of your phone. So now here is something your phone's calculator can't do. For example, it can store variables. So now what is a variable? Now variable is a character like this y. Now this is getting a little down in here. I will press backspace and I will go in here and press this clear button. I will check don't show this message again and press yes. It take it up in here so that you can see it properly. Now if I press like y, this is a variable and I will store a value with this equal to sign in this y. For example, I want to store 8. If I press enter, now y has been assigned to a value which is 8. Now you can see in here in this variable browser y is equal to 8. It is given a value 8. Now if someone asks how SciLab stores value, you will say SciLab stores values in matrices like in rows and column. Now it has stored this value. Now you will say why the name variable? Now variable is because if I want, I can change this value too. For example, y is equal to 9. If I press enter, now y has been assigned a value 9. Now SciLab can store hundreds of variables. For example, if I take any other variable, for example x, and I assign a value, for example 6. Now if I press enter, now x has been given a value 6. Now what if I want to add these two variables? Now x plus y, if I press enter now, it gives us 15, that is 9 plus 6, 15. See, it is not taking 8 now. The value has been changed to 9. So this is a really cool feature of SciLab that it can store variable, and almost everything in SciLab you can do with these variables. Now this console is where you will work like 40% of your time. But there is something more important than this console, which is this Sci Note. If you click this button, it will open Sci Nodes, that is this one. Now the difference between this console and Sci Note is that, for example, if I want to run a code, for example, I write a really big code and press enter. Now if I want to run it again, it will run that code similar to Sci Note. But Sci Note, this one, is a type of text editor. I can write, edit codes in here. I can also save it somewhere in my computer, and I can like open it in here, and if I press this play button in here, or this play button is like run, and this play button is like save and execute. It will save and run the code. So it will take this code and run it in the console in here. So now let's make our first basic code in SciLab. So this is really important. This is what you will do first to use SciLab. Now what we will do is to plot the function which is sin x, and it is really easy, don't worry. Now it is simple. For example, you will define a variable, for example x, and you will give it a value. For example, if I give it a value which is 90. Now for now we will give it 90. We will change this. Now I will say like y is equal to sine. Now sine have changed color, so this is a built-in function. Now let me increase the size. Now sine is a built-in function, so I will write sine x. Okay. Now whenever you need to display a variable, I have not executed this code, so this code is not yet executed. So for example, here x have the value 6 in here. If I want to see what value is stored in x, I will do this simply, that is disp brackets x, and if I press enter, it will show the value 6 which is stored in x. Okay, so whenever you need to display a value, you will use this command, that is, so see, you are learning commands now. So I have written x is equal to 90 and y is equal to sine x. Now I want to see what is the value of y. So I will display y. Okay, so this is your first basic SciLab code. Now if I save and execute it, now I need to save and execute it. So let's save it in here. Name it whatever you want and press enter. Okay, so it is saved and executed. Now if you go back in your console, see here it has given this value, that is 0.89. Here if I use a calculator and calculate sine 90, that is 0.89. Now you will say sine 90 is 1. So this is really important to learn. SciLab works in radians. So sine 90 radian is 0.8939 and sine 90 degree is 1. So whenever you are working with sine and cos functions in SciLab, always remember, if you want to work in degrees, you need to convert those radians to degrees by using the basic radian to degree conversion formula. Okay, so you have seen that SciLab have executed this simple code, it have taken a value of x 90 and y sine x and displayed the value of y. Now I don't want to take one single value in x. Now I will take multiple x values and put it in sine x and display it. So how will I do this? It is really simple. For example, let's start with 0. We want to go to 90. Okay, semicolon, and then the interval with which it will go to 90. For example, I want one interval, and this semicolon again, and then the final value. So this is the initial, this is the increment, and this is the final value. Now if I display y, let's see what happens. I click this execute. It will say save and execute because I have changed it, so save and execute. Now if you go to the terminal, see there are 91 values which are given. It is from 0 to 90. So see, SciLab stores values in matrices. So now see, in just 1 second or less than 1 second, it did this. It took the value of x, which is 0, put it in here and displayed by, then again it and put it in here and displayed that, then for 2, 3, 4, 5, 6 until 90 and displayed all those values in here. So this is the power of a computer. If you want to do it by hand, it will take days, but with this computer you can do it in seconds. So now let's do something more interesting than this. Instead of displaying these values, I want to see a graph of sine x. Can I see that? It is really simple. So to plot a graph, we use this command, plot brackets x comma y. Okay, so the x-axis is x and the y-axis is this one. So now if I save and execute this, see what will happen. This is a graphic window which has been opened, and see this. This is a weird sine function. You can see that it doesn't resemble much with the sine function. So what we have done wrong? The thing is that it have taken values for 0 and the next value is for 1. So it doesn't know where this sine function goes for the values between it. So we have to reduce this increment. So if I do this 0.1, now it will go from 0 to 90 with the increment of 0.1. Now it will go like this, 0, 0.1, 0.2, 0.3, then 1, 1.1, 1.2 until 90. Now let us plot it. Save and execute, and now we have got a decent sine function from 0 to 90 radian. This is 4 radian. So see this, we have just plotted something in SciLab, and this is the basic you ever need to plot any function in SciLab. Now we will see a lot of different programs and different functions in SciLab. Now this plot looks really bad because there is no like marking or anything in this. We can also make really good plots in SciLab. You will learn that further. But now see this. This sine thing in here is a predefined SciLab function. Similar to this, we can also define functions ourselves and run them in the terminal just by like chunking values. For example, I want to know how this sine x looks when this end value is 900. Then I can like put a variable in here, for example c, and define a function which takes a variable that is c. And I will like call that function, don't worry, you will see what, call that function in this terminal, and I will say like function, that it will be its name, and I will write the value in c, for example 1000, and then I will press enter. What will happen is this, it will call this function, and at the place of c it will put 1000, and it will like run this code for c equals 1000. So now we will see how to create a function. Now functions are really useful if you wanna like work fast in SciLab, so I've used them a lot, so that's why I wanna teach them to you too. Now take a look at this program. This is really simple, don't worry what is all this, this is really simple. Now how to define a function? You simply write this thing in here, function, and then this end thing in here, that is end function, and between this there is a function, and this is the function name. For example, in place of this you can write your name too. So for example, I can write like sine plot or anything. So I will keep it plot sine. Now this is taking this value v, and what is this value? We will see in here. This v is simply the frequency of the sine function, that is 2 pi nu x, and now this nu is the taking in variable. So now let's read this code line by line. This is function plot sine, that is the name of function. This is the input variable, and this is the x which will run from 0 and increment of 0.01, which is a really small increment, and it will go to 2 multiply by pi. It's just that 2 pi, like 0 to 2 pi plot is happening in here. Now y is equal to sine, and sine's function is this. We are just defining the period, which is 2 pi, and this is the frequency nu, that is the input variable, and this is the x thing in here. And like in here we are saying plot x comma y, which you have learned. Now this title is the new thing in here. Now this title will make your graphs look better. Now the title is that sine plot of frequency. And in this thing in here, whenever there is a variable, for example, I input frequency 3, so it will change this to 3. How you do this is this. Whenever you are writing some string, you write them in this semicolon. Always remember this. Okay, this semicolon, and this thing in here is the variable I wanna write. For example, if I write v only, it will take it like v and write v in the graph. So let us run this function and see what happens. I will just do this, save and execute. Now see, nothing happened, nothing have been plotted. Just clear this. Now see this, plot sine, and now I will give frequency, for example 1. Now see this, if I press enter, we get a sine plot of frequency. See here it is writing v, the letter v, not this frequency. One thing to note in here, and the frequency of sine function in here is 1 basically. So this is the sine plot. Now you have learned a lot of things. This is how we run function. We write the name of the function, and in brackets we write the arguments like first argument, second argument, third argument. For example, if there are other arguments, for example plot sine, there is this frequency v, I will write v first, and then if I like want to change that end value of the sine function, I can write another thing in here. But For that I need to rewrite the code to change this to a variable also. Okay. So now let's see what will happen if I do that string thing in here. So we add a variable in this string thing like this. We do this semicolon thing, this one, okay, a single semicolon thing, and we write plus on the both sides. This is saying add this variable in this string, which is the variable v. Now let us run this code. We first run this function. Now SciLab is like storing this function. There is a function named plot sine. Now it is just saying that we are redefining plot sine. Now I will call this plot sine. Now let's say 2. If I press enter, see what happens. Now see this, I have not closed this graphic window. So what this is doing is just plotting the new function above the previous function, which doesn't look good. So I will close this first. Just press the upward key and press enter. Now see this sine plot of frequency 2. 2 is taken from here. For example, if I do plot sine, now let's get excited. So plot sine this. If I press enter, see what happens. This is plotting for a frequency of 10,000. Here the sample space problem is coming in here. So let's decrease it a little bit. Plot sine. This is how we play with equations in SciLab. So frequency 100, 400, it's doing the same thing. So let's decrease the frequency to 15. Okay, so it should plot a good graph. So this is the sine function for frequency 15. Here there is some sample space problem at the edge, but it is fine. But you can see in here it is taking that value which we are giving. So this is how we add variables in the string. Now the good thing about this is this, that if I want to plot for frequency like 20, I can write 20 in here and leave it. But if in future I want to plot sine for like frequency 100, then I need to like reopen this code and write 100 in here, which is really bad and redundant. We just need to change the frequency and the plot will write that this is for this frequency. This is the cool thing about functions. Now the next thing I want to teach you is Linspace. Linspace is also really important in SciLab because this command, that is x is equal to 0 to 90 with the increment of 0.1, doesn't work every time. Sometimes in formulas there is a matrix error. There are really very unknown errors in SciLab, but there is an error which doesn't let this command to run. At that time Linspace is really useful. So now we will do this same thing in Linspace. So now this is how we do it. So we will type like lin space 0 to, we will write 90, which is the last value. 0 to 90, this is not the increment, this is the last value. And now instead of writing increment, what we do is this. The space between 0 and 90 is divided in how much parts. For example, I just want to divide the space between 0 to 90 in like 90 parts. So this is how we use Linspace. If I press Ctrl S and now run this command, so this is what happens. So this is similar to the command where the increment is 1. It has divided the 0 and 90 space into 90 parts. We can increase this by section by increasing this number. For example, now instead of 90 I want 900. Ctrl S. If you are a hotkey user, press F5 or Ctrl plus F5, but I like have the habit of clicking this one. So play, and now we have a decent sine x graph. So this is how we use Linspace. Now let's get a little more interesting. Don't worry, in this code there is nothing new. It is all you have learned with just some new things. So let's understand this code, and by understanding this code you will learn how to add graph elements, and it will make your graph look even better. So see this. Here we have defined a function again, and its name is sineplot2. Now it takes these arguments. So what are these arguments? It takes an initial value, it takes a final value, and it takes a n, it takes v1, v2, v3. So what are these? By reading this code we will learn that. So we have defined three axes in here, and in that there is Linspace and there is initial, final and n. So we have learned that these initial, final and n is the initial value from where our plot will start, and the final is the final value where the plot will start, and n is the number of sample spaces we will do. Now x2 is similar and x3 also similar, and also we have defined three sine functions. Now it takes this v1, v2, v3, and we have defined three v1, v2, v3, and what are these? These are frequencies. So that means that this code is for plotting three sine functions of different frequency. Okay, now one thing I want to tell you is that in this code there is something redundant that we do not need but is there. So what is that? You need to think and answer, and after some time I will tell you. Now after this we have plotted x1 versus y, this one, and then x2 versus y1, that is this one and this one, and then x3 versus y2, this one and this one. Now what are these weird things after this comma? Now what are these? Now this is really simple. This just tells the graph what to plot and in which color. For example, it will plot this one by using O, like the points will look like O's and the color of them will be R. Now for example, you want a standard plot but just color red, then you can write like this, like in quotes, in these quotes, minus R. Now similarly, this is telling the graph to plot with X and the color blue, and this is telling the graph to plot using star with the color green. Now this star, this O and X are nothing, just strings, because we have written them under these quotes. So always remember, when you need to tell the graph which color and which shape you need to use, you need to write them under quotes after a comma after you have defined the y axis. Now what is this thing in here? What does X label mean? So X label is simply the label of your X axis. It will label X axis. Now it is similar as defining title. We use two brackets, and inside those brackets add quotes, and inside them we write the string, and we use this thing under other quotes to add a variable which is n. So our X axis will say X axis, and it will say in brackets that sample points are n. That means this n that we will give to the function. Okay, now y label simply labels the y-axis. Now from here you can understand that how easy is SciLab. Simply y label name simply suggests that it will label y-axis. Now y label inside brackets under quotes fx is equal to sin x, so it will plot sin x. Now title, as you know, is basically title, and it title our plot under brackets inside two quotes. Now another thing I want to tell you is this. The only problem with these quotes is this, that if I want to write apostrophe s, now this creates a problem. That's why we can't write apostrophe and s in words in the graph. Now after this is end function. So our function is defined. Now let us run it. Now by running this you will learn a lot of things. Okay, so here it is saying that we have just executed that program. So now let's call our function. Its name was SinePlot2. Now remember that if you run the program only and don't create a function, etc, etc, it is fine. You can just press the play button and it will pop up the graph for you. But we are doing this function thing because it is really important. So now what were the arguments? Let us see that. So it was initial value, final value and the sample space. So let us give these initial value, final value. I just want the initial value 0 and final value 1. That means it will plot from 0 to 2 pi. Okay. And I want 200 sample spaces. Now what were the further arguments? Let us see them. These are frequency of first sine function, frequency of second sine function and frequency of third sine function. So now I want the frequency of sine function 1, frequency of second sine function 2 and frequency of third sine function 3, and that's it. Now let's press enter. So it has opened a graphic window and see what has happened. Now let us see the code and see what has happened in here. Okay, so in the code, we said that the first sine function should be plotted by using O and its color should be red. So let us see, did that happen? Yes, it is plotting using like these small O's and its color is red. And we said the second one should be plotted by using axis and its color should be blue. That's it. And other one was star. And now you can see the frequency of first sine function is 1, the second one is 2, and the third one is 3. And here we have the sine plot for different frequencies. This is the y-axis and this is the x-axis. But there is a problem in here, right? These are really small and looking really bad. So what can we do now? Now SciLab provides really good features to change this too. You just have to click edit and click this axis properties. Okay, so clicking that opens this graphic editor. Now in here, this gives you all the options you need to like edit your graph elements. Okay, so see this in here. This is your x-axis. Now if I change the size, see, the size has been changed and like I can also change its color too. You can like open this and play with these different things. This is really easy to use and quite intuitive. Now we will do the same for y-axis. Let me change the color to something dark. Okay, blue is, this one is also right. Now there is no z-axis, so no need to change that. Now the title is what needs to be like really big. Okay, so this is the biggest it can get. Now we will like close this. Okay, so now our graph is looking really good. So this is how we edit axis properties. You just have to go in here. So always remember that this is really important to edit axis properties. But there is a little problem with axis properties when we use loops. I will like show that to you after we learn loops. Now the next thing I want to teach you is this, that is legend. So a legend is a type of box that will appear in the top left side of your graph and it will make your graph look even better. What this does is this. You write the name legend and in brackets you write these square brackets with commas between them, and in that you write whatever you wanna write. Okay, and this simply takes the first one to the first plot you did, the second one to the second plot you did, and the third one to the third plot you did, and it will write which plot is which one. Okay, so when I will plot this you will understand it a little better. For now let us see its command first. So legend, these brackets, now square bracket, and inside them there are quotes and we will write a string in them, and in this string I have attached a variable with this command. Now the second one and now the third one. So this is simply saying that the first graph is for frequency this one, the second is for frequency this one, and the third is for frequency this one. Now let's run this. We have just redefined it and now we will like run it. Okay, so this is that legend. So the circle thing is for frequency 1, the X thing is for frequency 2, and the this thing is for frequency 3. Now anybody who will like look at your graph will understand it just by looking at it. Now after this you just have to go to edit and axis properties, and now you will go to this legend. Okay, because the size of this legend is a little small, that's why I normally like make it a little bigger. Okay, so this is how we add a legend. Now you should notice that in here this 1 2 3 is the variables that I have given to SciLab, and it have just attached that variable in here. If I change the frequency, this graph will also change and this one will change to the frequency that I have given. So this is the power of storing those variable and changing them, which you have learned at the start of this tutorial. Now one problem with legend is that plot something and we want something to show up in here too, this legend simply blocks the view. So we can also change its position by using pose argument, but the best one I use is this one. Now after writing the legend thing, if you write this comma and pose equal to 5, this pose means position. Okay, pose equal to 5, this gives you a really cool option. So now if I run that, we get this thing like With our cursor we can adjust where we want to like put this. Click here, it will adjust this ligand here. Now it is not blocking our view, so use pose equal to 5 to like adjust its position. There are different 1 2 3, but it like adjusts it in here, 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 here. With pose equal to 5 you can like use your cursor, stick it somewhere. Okay, so this was everything you need to know about ligand. There is also a little problem with ligand when we use loop. We will learn that further. Now a little thing I want to tell you is this. You are seeing this line, right? This one. This whole line is a single element. Now this is element number 1, this one is element number 2, and this one is element number 3. So there are 3 elements. You can also see this from here. If I go in access property, so here is saying compound 1, compound 2, compound 3. These are the elements. Okay, we will use this further, so do remember this. Now the next thing we will learn is subplot. So what if your teachers tell you that these plots are on to each other? I want in different spaces different plots of different frequencies of sin x. So for that we use subplot. It simply bisects your screen. So we use that command before plotting. So we write subplot. Now we write the number of rows we want, we write the number of columns, and we write in which one we are plotting for now. For this one we are plotting in the first bisection that we did. Now for the second one we want subplot 2, 2, 2. We will plot in the second one. Now subplot 2, 2, now we will plot in the third one. So this command is simply telling the computer that bisect the screen like this, then like this, and plot this one in here, then plot this one in here, and then plot this one in this part. Now let's save this and execute it. And now if we run that, see this, the plots are now at different places. First one in here, second one in here, third one in here. Now from here you can see that the title thingy we gave is given to the last one, because we have defined title things for this last subplot part. So it plotted that in here. If we like copy this, Control C, and paste it after this one and also after this one, then it will like fix all the problems. So now if we run that, first we need to like save and execute. Now we will go and press enter. So see this, it have given all the axis properties to every different plot. Now see this, we want this one to be in here, not in here. So this one is the fourth part. So we will simply do this. The third one will plot in the fourth side. So we will write 4 in here and Control S, execute. Now go to the terminal and run that again. So we get this one shifted in here. Now instead of 2 parts, I want 3 parts like this and 1 part like this. Then I will simply do this. For example, I will write 2, 3, 2, 3, and then this one 2, 3. I will save it, execute it, and then run it. See this, it have created 3 parts here. Now I can plot in this one too. If I want to shift this one in here, this is 1, 2, 3, the third one. So let's take this one to the third one. Okay, so let's go to the code. Here I have written 4. In place of 4 I will write 3. Okay, Control S, execute, close the previous graph. Now go in here, press enter, and see this, we have plotted 3 graphs above. Now this is how we play with subplot. So I hope you have understood what is subplot. If you have any queries, you can ask in the comment section below. Now the next thing we will learn is for loop. Now for loop is the only important loop we use in SciLab. There are other loops like while loop, do while loop, etc., but frankly speaking I've never used them. But what if I need to use it in some weird program? Then what will I do? I will simply go in here. This is the help icon, which is the answer to your every problem, and write while or anything you want to learn new. Press enter, and now see this. It is telling me how to use while loop, its syntax, etc. So it is as simple as that. You just need to go to help section if you want to learn anything new about SciLab. So now let's come back to for loop. This is the only loop you need to know to plot virtually anything. So I will teach you this one. So we have just defined a function named for loop, and it takes a variable w, which is something in our for loop, and this is the end function. Now for loop starts with the name for, and then there is a loop variable n which will be used in the loop. Now that is equal to, it starts with 1, and the increment, whenever there is something semicolon type thing, the center thing is increment, not like Linspace. It is not the end value, this is the increment, and this w thing is the point till our loop will run. And inside the loop we have just displayed this value of the loop variable, like what the loop does. We just wanna see that. Now we will run this code. Now let's see what happened in our terminal. Nothing happened because it was a function. Now I will run the for loop function. I want to go till, for example, 10. Okay. Now I will press enter. See this. It started with 1, went to 3, 5, 7 and 9. This is what our loop is doing. So now let's get a little more interesting. Now we will initialize a variable, for example y equals 0. This is called variable initialization. This is done before running a loop. If you want to use some variable in the loop, do this, because sometimes when the program ends there is a value of a variable stored, and when you again execute that program it starts with that value and everything messes up. So this is called initialization. So for example, we take a variable y equal to 0 and another one y1 equals to, for example, 0, 2. We have initialized this variable 2. Now what we will do is this. So we will write y equals to 1. Okay. And we will write y1 equals to y1 plus y. So what happened is this. We have just initialized a variable. We can write y equal to 1 in here too, but I just like written it in here. And now what will happen is this. This loop will run till 10. I will like increment 1 in here to run 1, 2, 3, 4, 10. And the value of y is 1. And the value of y1 is 0. In the first one, n is equal to 1 and y is equal to 1. And y1 is equal to 0. So y1 plus y is equal to the new y1, which is now 1. Now the loop will run again, and then y is equal to 1. Then the previous y1 was 1. Then 1 plus 1 is 2. Now the new y1 is 2. Then this loop will run again. Then y is equal to 1. Now the old y1 was 2. So 2 plus 1 is equal to 3. The new y1 is 3. Similarly till 10. Okay. So now we will display y1 how it is growing. So let's run this. See this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this program is simply adding every loop value to y1. This is how we add a value to y1. Why I'm teaching this is because in a lot of formulas we need to like add things, like in square wave function. See this, we have done the same thing. This is square wave. If you don't know what is square wave, etc., just skip this part. Square wave is like a function, and we plot it using Fourier series, which simply adds different type of sine functions together to get square wave. So see this in here. Similarly initialized these variables, and we have run the for loop by increment of 2. This is because in square wave we take n as 1 and then 3 and then 4 and then 6 and so on. This is some mathematical physics stuff, don't worry if you don't know that. And then we are just adding that y1 to a y. This is how we add a for loop and get the final function, and then we are plotting it. So this is why I have taught you how to add new functions. For example, in here we have not used the loop variable anywhere in here. So what will happen if do this n? What do you think will happen? Firstly, n will be 1 and y1 is 0. So n plus 0 is our new y1, that is 1. Okay. Now the loop will again start. Now n is equal to 2. The y1 was 1. So 1 plus 2 is 3. So the next y1 is 3. Similarly, this loop will go on and we will get a output like this one. Okay, so let me clear this and now we will run it again. See this 1, 3, 6, 10, 12. So this is how we can also use the loop variable in the loop itself, or we can just use the loop variable to run a loop and do some operation, or we can also incorporate loop variable as we have done in this square wave function. I don't want to go in much detail of this because this is not the scope of this video. I just want to teach you SciLab. Okay. Now we are at the end of this video and I will teach you how to plot Planck's law now. So those who don't know what is Planck's law, don't worry, it is just a law which is used to plot the spectrum for black body radiation. And those who don't know what is a black body, don't worry, this is just a formula, this one and this one. We just need to plot this x versus v to get a curve like this. So the first thing you are learning in this grand code is this, that is how to comment. So what are comments? So comments are just some lines which you add in the code. For example, someone else is reading your code, he can understand what you have written in here, what are you doing in here, what are you doing in here. Or if I myself read this code after a long time, I can understand what have I done. For example, I have written in here setting graph elements and I have like commented it. How to comment? We just use this /2 comment. Now SciLab won't read this, it will accept it as a comment, just a line, it won't execute this or like don't give errors regarding whatever I type in here. So this is how we comment in SciLab. The second thing you are learning in here is this E thing. This E thing is just for writing that 10 raised to the power something. For example, this is the value for Planck's constant, which is 6.6 into 10 raised to the power minus 34. And this is the speed of light 3 into 10 raised to the power 8 meter per second, and so on. Different constants are declared in here. So let's understand this code. So here is the value of Planck's constant that we need in here. Here is the speed of light that we need in here, and here is the Boltzmann constant that we need in here, and here is the temperature that we give and plot in different graphs of Planck's law, and we need that in here. Now we start a for loop, which is the most important loop, and we start the frequency range. Like Planck's law is plotted for a range of frequencies or wavelengths. So it is starting from this, that means 100 into 10 raised to the power 0, that means 100 hertz to 750 terahertz with a gap of 3 terahertz in each step. So now I have declared this x. This x is basically the thing which is in the exponential of the Planck's law. We have just declared it somewhere else so that we can like plot that versus this. So this is the x, that is h nu upon kt, and this is the formula for Planck's law. Now see this. This plot thing in here is declared inside this loop, not outside this loop. This is because when we will run this code, SciLab will start with 100 hertz. It will calculate this and will calculate this and then plot one single point in that graph, which is x versus b. And then it will go again, it will get the other frequency and then calculate this and then calculate this and then again plot it and so on. So it will plot like one at a time. So every single plot in that graph will be a different element because we have used the plot command inside the for loop. So understand this, that it will use this plot once, then again, and then again, and then again, and then again. Now the question arises why we have done this. This is simply because if we take this plot thing out of this loop, what will happen is this: it will calculate everything, and we'll just plot the last value, which is 750 terahertz one, in the plot, and we will just get a one single point. So now after this is just setting graph elements, ligand, title, x level and y level, nothing new. Okay, so now let's run this and see how we get different graph elements. So I will save and execute it. So now I'm getting a graph. Now look how this graph will be plotted. See this. This is plotting single points. Now, one point at a time. This is calculating the loop, calculating x and then b, and then plotting that single point. Now, every point in here is a graph element. Remember this. That's why this time it is slow, because when we plotted sine x, it just plotted in an instant because it was just single graph element. But now these every single dot you can see in here is a different graph element, and this whole thing is representing the Planck law. This is a Planck law at the temperature of 3000 Kelvin. Okay, now if I go in this axis property, take a look. Okay, so see this. That time when we plotted sine x, we had 3 compounds only, but now see this. We had a total of 250 compounds. That means these are different 250 dots. Now another thing I want to show you in here, I have written 3 different temperatures in this ligand in here. The thing you need to look now is this: when I will change the size of this ligand, what will happen? This is the x-axis. It's working normally, right? I am about to show you a problem with SciLab and how to resolve it. Okay, now we will go to title and increase its size. So it's working normally. And if we go to this ligand, I have defined 3 different temperatures in the ligand, and it have taken red because the first 3 plots, like the plot x, vx were red, so it has taken red things in here. This is just because I have written 3 different temperatures in here. Why I've written them? Because now after this we will define a second temperature and we'll show you what happens then, and we will also define 3 temperatures and see what will happen then. So now if I open this thing in here and increase its size, it acts normally, so not a much big deal. But if we plot for 3 different temperatures, let us see what will happen then. Okay, so now I have done nothing, just defined 3 different temperatures: 3000 Kelvin, 3500 Kelvin and 4000 Kelvin temperature, and this is the for loop running under these temperatures, and it will plot 3 different Planck's law onto each other. So now let us plot it and see what happens. The thing to concentrate in here is that this one is with red color, this one is with blue color, and this one is with green color. Okay, so now let's run this code. It is first plotting the red one, and now see this, it's plotting the blue one, and see this, now it's plotting the third one, which is in green. Okay, so it is finished plotting. Now the first problem we are seeing in here is this one, that is the temperature for 3000 Kelvin is showing red, which is correct, but this one are wrong. This is the blue one and this is the green one. So we need to correct this. The problem is that the ligand take the first 3 plots which were red and giving this the color. But the thing we wanna show in the graphs are these 3 different plots, and these 3 different plots contains a lot of different 250 elements. So to give this ligand right colors, we will do dummy plots to give this right color. So this is how we do that. So just take this command, okay, and I will paste this command in here, and the second command, and I will paste this command in here, and the third command, which was the green one, I will paste it in here. Okay, so now the first 3 plots are red, blue and green. Now the ligand will just take the things red, blue and green. Okay, so now let us run this one. I will let it plot. So see, it has plotted and now the colors are right. This is because of the dummy plots we have given to our graph. Now this was the first problem with plotting with for loop. Now the second problem comes when we change the size of this ligand. So now I will click this axis properties. Okay, so now see how many compounds we have in this single graph. See this, these are 753. Okay, so now if I change these axis properties, for example, the size of x-axis. Okay, so this is the size of x-axis changing normally, the size of y-axis label, and the size of this title. Okay, so these change normally, but when we click this ligand, see this ligand box came. Now if I change this font size, nothing happens. I don't know what is the reason, but this will automatically close again and it will automatically open again, and then it will again close and open. And when it will do this the third time, I've done maximum of 3 plots, this size change and everything works normally. So this is I wanted to tell you. Now see this will like close automatically. So now it has opened the third time. I just skip the things. Now if I change this, the size changes normally. So this is I wanted to tell you, like if you click this ligand and nothing happens, wait, it will close and open automatically 3 times normally, and the things will work normally. So this is just I think a bug or something or some problem with these for loops. So now with this, you should be able to plot almost anything you want in SciLab. Isn't it cool? But now the thing left is 3D plots, and in BSc I have not done any 3D plots yet, but if I do those 3D plots and learn a lot about them, for now we have just done like a Bessel function, heat equation plots. Those are not much, and I don't think I can teach you much about 3D plots now. So if I ever learn about 3D plots and I get good response on this tutorial, I will make one on 3D plots too. So another cool feature of SciLab is this one, that is this is Xcos. I have also never used it. You can use it to like realize circuits, and that is also cool, but I have also never used it, so we'll make a tutorial when I learn that too. So thanks for watching this video. I hope this tutorial helps you, and always remember that math is everything.